going to continue 6.2, and we're dividing radicals today. In order to divide them, just like yesterday, when we multiply them, they have to be the same size, right? So, first thing must be the same dimension or size. So in order to divide them, you have to have a cube root over a cube root, fourth root over fourth root, and so on. Here are the steps I would like you to consider. Step number 1, I would like you to reduce the fraction if possible. So just like we did in the warm-up, how both of those could reduce, that should always be step number 1. Step number 2. After you've reduced the fraction, the next thing you should do is see if you can simplify the radicals. Step number 3, if you still have a radical in the denominator, we can never have a square root, cube root, fourth root, anything. We cannot have a radical in the denominator. So if you still have one at this point, now you have to rationalize. Step 4, once you rationalize, simplify. Oops, helps if I can spell right. Simplify if needed. All right. So obviously we've talked about reducing fractions. We can handle that part, right? We talked yesterday on how to simplify radicals. So we know how to simplify a radical. The real question is, do you remember how to rationalize? So let's talk about rationalizing and make sure that we remember how to rationalize. When we rationalize, it is our way to eliminate a radical in the denominator. All right, so for example, what I know you have done before is if you have 1 over the square root of 5, we cannot have a square root of 5 in the denominator. So what did we do to get rid of it? We have to multiply by the square root of 5. And whatever you do to the bottom, you got to do to the top. Exactly. So in this case, 1 times the square root of 5 is the square root of 5. And on the bottom, the square root of 5 times the square root of 5 is 5. Exactly. Okay? Because technically when you multiply these two radicals together, you actually get 2 5s, so it can come out as one group, right? Yes. Bear with me for a second. This is your final answer. You can't do anything else with that. That's it. It's done. Okay, let me say it again, gentlemen. All right. I was just saying over here, Gabe, that when you multiply the square root of 5 times the square root of 5, technically it's the square root of 5 squared, or 25. But you simplify that, and a group of 2 5s can come out as a 5. Yes. There's a reason I was saying that. So, here we go. Let's say I have 1 over the cube root of 9. So, as I continue, if we were to break down 9, that is 3 times 3, right? But it's a cube root. How many friends, or how many of the same thing do I need? I need 3. So when I rationalize, I have to multiply by the cube root of however many more I need. So how many more 3s do I need? 1. We need 1. So I'm going to multiply by the cube root of 3. Whatever I do to the bottom, I'm going to do to the top. So on top, 1 times the cube root of 3 is the cube root of 3. On the bottom,
9.
no. It's the cube root of 27. You guys, please listen. Thank you. On the bottom, I now have in this cube root 3 to the 3rd power. We have 3 3's, which comes out as one group of 3's. So we can just get 3 on the bottom. Okay, try another one. If I am rationalizing, let's try another one with the cube root. Let's say I have 1 over the cube root of x. Again, to rationalize, I have to multiply by the cube root of whatever's missing out of my group of 3. I have 1x right now. How many more x's do I need? 2. So this will be the cube root of x squared. Whatever I multiply the bottom by, I have to multiply the top by. On the top, 1 times the cube root of x squared is the cube root of x squared. On the bottom, I have the cube root of x to the 3rd, or x. Okay? Let's try one more. Just to make sure we're understanding how to rationalize, right? All right, let's say I have 1 over the 4th root of a squared b to the 3rd. All right. So, again, in order to get rid of that radical, I need how many of each thing? 4. Okay, we need 4 total of each thing in order to get rid of the radical, right? So I'm going to multiply by the 4th root. And what did you say, Gabe? How many more a's do I need?
2.
Okay, and how many more b's do I need? 1 b. Whatever I do to the bottom, I have to do to the top. So I get a squared b on top also. On the top, 1 times that is still the 4th root of a squared b. On the bottom, it would just be ab, yes. That's the whole goal, is to get rid of that radical. If I multiply these together, it would be the 4th root of a to the 4th, b to the 4th. All right? I want you to see what it is you're missing. That's why I started to write it that way, having to do with the radical. Okay? I know, I like it. Thank you. Gentlemen, if there's an issue, I'm done. Seriously. All right. So here we go with example number 1. We're going to start by just simplifying, which is all it's asking you to do for 38 through 42. So here is our first one. Let's say I have the cube root of 40 x to the 5th over the cube root of 5 x. So our very first step is to reduce this fraction. Imagine they're all underneath one big radical, and we can reduce it. So I have 40 divided by 5 is 8. And then if I have x to the 5th over x, I get x to the 4th. That was step 1. Step 2 says just simplify the radical. So out of this, I can break 8 down into 2 times 4. 4 is 2 and 2. So we can take a group of 2's out because I need 3 of them. So 2 can come out. How about out of x to the 4th? 1x. And then staying at home without friends is the other x. So for this one, it was only steps 1 and 2, right? Example number 2. Let's go with that. What is the first step I ask you to do? Reduce the fraction. I really want you to focus on doing that because they're going to get bigger. And we need to make them as small as possible before you start to simplify. We reduce. So on this one, and I've just got square roots, right? So 20 over 45 reduces to what over what? 4 over 9. I agree. So I have 4 over 9. How about the x's? What can I do there? So I can take and cancel this x with one of them out of here, right? So I have no x's left on top, but x to the third on the bottom. All right. What about the y's? Can I cancel the y's anywhere? All right. So now I have the square root of 4y on top. How can I simplify that? What can come out of the top? It's a square root, so a group of 2's, right? So on top, I would have 2 square root y. Talk about the bottom. Take out a 3, and what else? And 1x. All right, is everybody good with that step? Okay. Now, because we still have a radical on the bottom, we're to step 3, right? We have to rationalize. So this is a square root, which means I'm multiplying by the square root of the factor I'm missing, right, which is just x. Whatever I do to the bottom, I have to do to the top. So on the top, multiplying those together just like we did yesterday, you should get 2 square root xy. It's inside. Remember yesterday we multiplied our outside, so 2 times 1. We multiply our insides, x times y, right? On the bottom, 3x squared, I agree. The 2 here come out as an x. That x with that one right there makes it x squared. Is there anything to simplify now? Nope, we're done. This would be your final answer. All right, example number 3. All right, it's a little closer to what you're going to be doing for 44 through 50. The directions ask you to divide and rationalize. Let's start off with the cube root. Yes, you should still always, when I say divide, you should always do those same steps every time. Okay? So I have the cube root of y over the cube root of x squared. Can I reduce this fraction? Okay? Can I simplify either of those radicals? So now we're to step 3. I still have a radical in the denominator, so I have to rationalize. I'm going to multiply by the cube root, and what factor am I missing? Just 1x. Whatever I do to the bottom, I have to do to the top. On the top, we have the cube root of y times the cube root of x. We get the cube root, xy. On the bottom, just an x. Is there anything to continue to reduce here? Simplify. Oh, you're done. Let's try a little bit harder one. How about this one? Let's say I have the cube root of 5x squared y over the cube root of 10x y. We'll just say y. All right, so the first thing we want to do is reduce this fraction, right? Yeah, so 5 goes into 5 once, 5 goes into 10 twice. What about the x's? How can I reduce those? Yeah, so I can get rid of the 1 down here for one of them up here. What about the y's? You can get rid of both of them, right? So after we reduce that fraction, we have the cube root of x over the cube root of 2. Okay. Does everybody agree? After we've reduced that fraction, we're left with the cube root of x over the cube root of 2. All right, now, I still have a radical in the denominator, so I have to multiply by the cube roots. I have only 1 2 here, which means I need 2 more 2's. So what am I multiplying by? 2 squared or 4. Yes, right? Whatever I do to the bottom, again, I got to times the same thing on the top. So on the top, I have the cube root. X times 4, or 4x. On the bottom, I technically have the cube root of 2 to the third, right? There were 3 2's, or 8. I can just take out a group of 2's, so I get 2 on the bottom. Example number 5. Yeah, there's nothing else to do. All right, what if we had something like this? Let's say I have 15 square root of 60 x to the third over 3 square root 120 x. So, first we want to reduce it. Let's start on the outside of the radical this time, because I haven't included anything outside the radical yet, have I? What can I reduce outside? Yeah, this 3 will cancel with a 15, so I just have a 5, right? Okay, let's talk about inside the radicals. 60 goes into 120. How many times? So 60 is canceled. This is just a 2 left, right? 1 over 2. What about the x's? And take 1 out of here. So right now we are currently left with 5 square root x squared over the square root of 2. So now, step 2 says to simplify if you can. Well, just a minute, what can you take out of that top square root? The x, right? So my next step would be 5x over the square root of 2. Last thing, I still have a radical in the bottom, so I have to rationalize. So I times by the square root of 2. Whatever I do to the bottom, I have to do to the top. So I get 5x square root 2 all over 2. Okay? So as soon as you took this and it was big and ugly to begin with, if you reduce the fraction and make it as small as possible, it makes it easier, right? If you then go ahead and simplify the radical, it again makes it even smaller to work with. Irene?
So you kind of, like, instead of reducing, like, on the top here, I could get 5 and then square root of 60 and start taking things out of the square root? No, right?
Well, you can do that. What happens though, Irene, and the reason I teach it this way is when you start taking things out, you get all this stuff on the outside again, and you're going to have to reduce them. You know what I mean? So it just makes more sense to why do that step if you've got to reduce it here anyway, right? Yeah, I'm trying to save you a little bit. All right, so you have 7 problems for homework. 38 through 50. You have 13 minutes. I expect everybody to stay in their seat and work for these 13 minutes.